Hello everyone and welcome. So today I got on my hands Evga 3070 XC3. This one is not functional. I was told that it died after power surge and now it doesn't post. It gives some red light, whatever it means, I don't know. But we're gonna find out. From an interesting thing, it has a peel, so no one was peeling that previously. There are some dust, a little bit restricted airflow, and Evga factory seal. So previous owner already tried to turn it on many times, so I don't think it's going to be any problem, even if it's, in not a great condition to test it. Probably my best guess is going to be that VRM fried and it just, shorts 12 volt to the ground, but we're going to find it out. Display port, and then let's see what do we get. Okay. So PSU is actually powered on. Car doesn't spin any fans. Oh, okay, look at that. So there is 8-pin detection red light. So that may be actually a good thing or easy thing to do. So I'm gonna power it off, disassemble, and we'll find out what's going on inside. So since we just checked that there is red light over here, and if you can take a look, there are 3 LEDs. So 2 of them are for 8 pins and 1 of them is for probably 12 pin PCIe. So I'm gonna go ahead and disassemble this card, and I finally gonna peel it. So I actually may not need to peel it. I mean, eventually I will, but for now, just for disassembly, I'm probably gonna keep this peel on for not scratching backplate. But yeah, I thought it's completely, VRM completely fried, shorts and everything, but that's kind of interesting. I'm not sure how the 6-pin detection died and what's going on over there. It should be like, normally it should be like a couple of transistors which take care of, this detection. But on some, oh, look at that, there is not. But at least on the older cards, this detection actually was going all the way to GPU, like on this 7800 GT Dual Extreme I was fixing other day. So time to destroy the seal. Okay. So let's see. I don't know if there's anything on that part of backplate. There are some actually thermal pads. Let me grab the plastic tool and pray it's okay. So we got thermal pads over here in the VRM zone. Then we got thermal pad underneath the GPU, and for that there's a resistor. I'm not sure what this thermal pad is doing over here. So that's quite interesting. Maybe there is some PWM controller or memory power rail. I don't know. So this thermal pad, yeah, probably gonna be destructive to remove it. Because, I mean, it's aged thermal pad, and that one doesn't look like it's a, silicon-based. Well, actually, it's not that horrible. Probably since it is a thick thermal pad. So that's easier to remove in non-destructive way. So I guess, we can already get started with and do some measurements, just like a quick measurements. Do we have any shorts over there, even without going deep to the GPU, just to check. You know what, nah, I'm gonna disassemble it and see what's going on another side. Let's see. So over there we have 3 tiny little screws, and for that one I need to grab really small screwdriver like that. So remove all of the IO screws. I'm wondering that they didn't put anything on HDMI, but that's okay. So IO bracket, I don't need it for now. Can put it on the side. Now we can get back to our card and remove these 4 screws. That's actually interesting. It's not a square pattern. There are some transistors over there, like bigger one, but they may actually be for the fans. And speaking of what, I may want to disconnect them first. So let me see if I can grab something like tweezers and pull it. Come on. Okay, never mind. I guess I will need to move the shroud with the radiator on the side and do the rest. So, yeah, as you can see, the last thermal pad was in this area, and I'm not quite sure. It says 1.8 ohms, so there is something over there. Oh, actually, I see there are more of those resistors on this side, so probably it's a little bit of VRM. And we can check some fuses. I see there's 8 amp fuse on the PCA line, but I assume this is, I mean, it's fine because our LED is not shining for PCIe. Those, yeah, they hold decently well. So now we need to separate card and heatsink. And that one sits pretty well. So I'm gonna try, slowly, gently pull that. Okay. Now from another side, over there, it's mostly probably sitting on thermal pads, not on the thermal. Oh, look at that. So we have connector over here, which he doesn't like. So they put connectors on both sides, which is not my preferable thing. Those, okay. Oof. So they use thermal paddies over there. Let's see if I can unclip those relatively easy. Come on. Come on. Damn connectors. I hate those connectors. I mean, those look slightly better, but in reality, they are still not good connectors. I mean, they are placed in really annoying location. So they are pretty tight. They have a tight fit, so. Okay. So now we separated our GPU and the heatsink. So over there we got some thermal paddies. Yeah, thermal paste, look brand new. Whatever does it mean. Over there, I don't know, 4 thermal, 4 heat pipes, 4 plus 2, 5 over there. So I'm gonna put it on the side. I'm not that much interested in the radiator, but I'm interested in the PCB. So PCB, relatively small, 2 fuses over there, then 1 bit of VRM right there, which doesn't have any cooling. So that's what I guess. This is probably like, VRAM, then main GPU, and that one maybe something for like VDDCI or anything like that. I'm gonna remove this thermal pad, and later I'm gonna measure. Oh, actually, let me measure it right now, because I will need to replace them with something. Okay, so let me grab my tools. So 186 when you squish, and 196 when it's good. So it's 2 mil thermal pad, which is fine. I mean, it's I would say it's a little bit thick as for me, but hey, that's good enough. So next thing, I'm gonna clean up the GPU, and we're gonna inspect which chip do we have over there. It should be GA104, if I'm not mistaken, but I'm wondering, is it LHR, regular one, maybe some, interesting revision of it. And for sure, manufacturing date. I see one cap, which for me looks odd. Yeah, it definitely looks off. So let me show you that right away. So over there, we have this cap, which left the chat, so I'll need to put it over there. I need to save it and not to lose it somewhere. So that's gonna be quite challenging. But we're gonna put it back in a second, in a moment. Let's be realistic. I won't put it down right away, right now. Because I was like, this cap looks like it's loose. And I'm gonna put some IPA on the GPU. Yeah, thermal paste is pretty dry. So I guess this GPU had some use. And I'm gonna grab my plastic tool and quickly inspect the rest of capacitors. Yeah, the rest of them looks good. Okay, so, and that one, that's the reason I don't like thermal patties, but it is what it is. They are, you know, ugly to maintaining. So over there, we got J104 302A1 from 2022-16, so it's relatively fresh. Then for memory, you probably can grab it from there or from there. MOSFETs, one tiny little phase, and then PWM controller, maybe somewhere over there, which is UP. I'm not a huge fan of them. Usually it's harder to find documentation of that than on semi. And on this side, we have a huge chip, which probably just microcontroller for RGB and fans. And that one may be actually something related to power measurement and balancing. And there is one more tiny little chip, which I even can't see what does it say. And a bigger on semi. So let's take a look, and then I'm gonna put this cap back because I don't want to hold it somewhere on the side for quite a while. But at the same time, I don't want, you know, mess up this GPU right now. So let's do a quick measurement. So our baseline is 0.3. I'm gonna grab this HDMI and see whatever you are, kilo ohms, somewhere over here, 12 volt PCIe, kilo ohms, good. This tiny little thing, 13 ohms, maybe questionable. Memory rail, which I would assume memory rail, 35 ohms, looks fine for me. Then something which I don't know what is that. 2.7 kilo ohms, good. This one, a lot of kilo ohms. This 12 volt inductor from 8 pin, kilo ohms. Another one looks dead. So let's find out where it goes. And from a quick sync, looks like it goes to this shunt. Actually, I'm surprised. So it goes to this shunt. Yeah, but the memory, I would assume that it goes to the memory rail because it's somewhere here. So let's see on another side, what do we have? So this, actually, let's check those fuses. So this one looks like this one probably gonna be blown. Yep, that's a dead blown fuse. So let's see. Ground, I need to go all the way over there. Kilo ohms. That one also goes for kilo ohms. Wondering which one of this. Yeah, so that 8 pin goes over here and it gets shorted, and I mean, this current shunt, good. So now I'm curious, what is our, actually, there are some test points over there, which I wasn't aware of, and I have no idea what are they for, but that's interesting to know. And this one should be RGB. So let's grab the ground again from HDMI, and let's check the rest of stuff over there. So 12 volts or 3.3, I would assume 12 kilo ohms, GPU core. Give me something more than 5. 4. I would say that's pretty low, considering that my multimeter gives me 0.2. So 0.2 ohms, I would say that's already questionable value. Fuse over there, I would guess it's fine. Yep, fuse is fine. And that rail, I don't know what this one goes for, but this one goes to the ground. This one goes directly to the ground. So that's actually a good thing. If GPU by some reason still alive, it has some chances. So again, probably from a quick and easy thing, I just gonna grab 1 volt, feed it over there, and see with thermal camera. I'm gonna inspect what's going on. So give me a moment. I'm gonna grab my bench power supply, tune it to get like 1 volt, maybe like 4 amps, not too much. I don't want to fry everything. Okay, so 0.9 volts should be good. I'm gonna grab HDMI, or maybe actually, there are better things to grab, like this display port. And then on the positive terminal, I'm gonna grab this thing. And I'm gonna grab my thermal camera. So that's what we see. I mean, there are some reflection and this kind of things, but for now, 5 amps going somewhere. So it should be noticeable, but I don't see anything. So let me shut down the light. Now it's gonna be sketchy, and you're gonna see probably nothing. But I wanna take a look on the thermal camera, what's going on. So that's my 12 volts input right there. Come on, let me put it back. I don't see a thing. Wait, is it just shotgun? Oh, something is wrong with my power supply, huh? Not sure what, but yeah, give me a moment. So I fixed the issue with my bench power supply. I just needed to restart it. I'm not sure what's exactly happened to that it, stopped to work, but I'm gonna shut down the light and connect it over there. So what do we see? Actually, let me maybe grab the camera slightly different way, So I'm gonna grab this shunt resistor. Let's see, so GPU, mostly reflection. There is there is also reflection. Okay, I see something over there is gaining the temperature. So let's turn it back on. And over there, yeah, where's my finger? Over there. So that's actually VRM area. So I'm gonna remove the thermal pad. Looks like one of the faces just got blown, which surprised me a bit. And I'm wondering, oh no, I wanted to say I'm wondering, is it the memory phase? Because on more fresh GPUs, at least NVIDIA started to put some memory phases around the main GPU VRM. So I'm gonna check. This thermal pad also looks like 2 mils for me. 189, yeah. So 2 mils pad, and I'm gonna grab the cotton stab and slightly clean that and repeat our testing. But from not good thing, it's somewhere in the middle around a lot of those caps. So that's something which I don't like. But hey. So let me try to push it slightly closer, and then let's see what's going on. Okay. Let's see what's going on. Oh yeah. Actually, okay, I just didn't have a proper contact. Okay, over here, this is a heating spot. So let me grab my macro lens and see in details which one is heating up. This is the one. I mean, let me slightly increase the current. So I'm gonna see the better picture, because I mean 33C, I would prefer to see some more. Oh yeah, 40, it's already heating up, yeah. So actually, let me try to take a picture of that component heating. Come on, enchant, Raya. Yeah, and it really quickly cools down. So let me just calculate properly. What do I see? 1, 2, 3, 4. Actually, I can check it. 4. Yeah, right in front, inductor number 4, we have that heating component. So yeah, really not a good location. Let me do one more. Yep, it's right near with inductor number 4. So we found our dead phase. So this is that one. That one looks dead. The problem, it's going to be tricky to get this one off. It also can be a thing that there is something on another side, like the capacitor, like this one. So 1, 2, 3, 4. This cap may be blown, because I mean that's location is pretty at the hot spot. So probably first thing, I will try to remove that capacitor and see. Oh, actually, since I already know, let me actually do some measurement. If that cap, so let me see. I'm gonna try to do some. So 001, this cap says 003, this one, also 003. And then, I mean, obviously, yeah. So let me try to remove the cap, or since I already know that the problem is on this side, let me see if I can reproduce it with a thermal camera. Because maybe this side of board gonna hit more, and that can give me some clues. Because I really don't want to, remove that VRM component. It's not handy at all. So let's see, and actually I'm gonna grab the macro lens right away. So I'm gonna touch the cap. Where do we have this? Somewhere over there. So that then those caps. Okay, I see it. So let me try to touch it from this side. It goes hot. On this side, it goes even hotter. So yeah, actually, if I touch this one, it goes this way, this side, It goes, so this side goes only to 40C. This one, yeah, I mean, I will try to remove that one and see if I'm gonna get any difference. It is, it's heating up, but it's not that obvious. I can't say, is it like cap for sure, like cap problem, or is it, you know, the MOSFET on another side? But the cap for sure is way easier to remove. Nope, doesn't look like a cap problem. Yep. And just to confirm that, we can grab this, and it's still gonna be on the ground. Yeah. So power stage is our culprit. Now is gonna be not a fun part, because I'm actually not quite sure how I'm gonna remove it. I'm probably gonna put it on my infrared, I'm gonna preheat it, cover the caps, and try to use a heat gun to remove it. So we'll be there in a moment. So the card actually passed already cool down state, so I'm going to put it on the side. And actually, I quickly took a look. This 302, that's actually an LHR GPU, so not the best one. I mean, from gaming perspective, it doesn't matter, and I doubt that anyone minds. So let's check our power stage. So this one is 0, this one is 0, and this one is 0. So this one completely shorted. So yeah, that's a dead one, and I will need to put this cap back. Now let's find out, did we get out of our short? Look at that, kilo ohms, beautiful. From a good thing, and actually now we can check our GPU resistance. Let's see if it increased. So let's get the baseline. So now it's completely 0, 0, 1. GPU, it doesn't look good, to be honest, but we'll find out. From a good thing, I can just, for now, I can just ignore this power stage. There are plenty of them, more than enough to feed the juice for this GPU. That power stage is this one, so you'll need to find the replacement of that. And also, I will need to find the replacement for this dead fuse. So for now, I'm going to go ahead and put that capacitor back, because there's nothing wrong with it. On the top, and then we grab this tiny copper wire. And I'm gonna put like 3 layers of it. So let's find out now. That's the card which we just worked, and that's a VRAM which is missing over there, and that's fake fuse. So let's see. And actually, I don't know if it's gonna work on X58, because I know that 5000 series GPUs, they don't work on X58 by whatever reason. But I mean, if it doesn't post and if it has voltages, then I'm gonna grab another board and test bench it. So for not leaving this shiny thing unprotected, I'm gonna put some heatsink, and on top of that, I'm gonna stand the fan right there. So let's find out. And actually, right away, I'm gonna prepare the multimeter to check the voltages. Let me use my favorite ground from the Molex and make sure. Yep, 5 volt. So what do we have? 136 volt over there, some voltage, 1 volt over there, both 12 volts. Come on. GPU core, 0.78. So in theory, GPU should heat up. And it does. Look at that! It works. It damn works. So yeah, one power stage is dead, but we are good. So I remove the Kaplan tape already. Power stages. One more thing which I forgot to mention. I put back this capacitor, which previously lost, and that's the power stage which I'm gonna need to order. But for now, it should be good enough. I will clean up mostly all of that mess. So just a quick check, we just assembled the card, and I'm gonna plug it in, make sure that it's posting, and then it's gonna come to the boring part. I'm gonna install Windows, so I'm gonna do it off camera. For now, I'm just interested into this card to post again as it did, and if it does, then we are good. And I don't see the reason why it wouldn't, but you know, thing happens. No LEDs. EVGA logo is shiny. Yeah, yep, it does post. So, and fans just stopped. So we are good. So I have the card up and running on my X58 test bench, and I already pre-installed. I installed the Windows. I pre-installed some software like benchmarking. I wouldn't go really crazy. I'm just gonna run Heaven and superposition. So that's gonna be for initial testing. And let's take a closer look. So we have 3070 LHR as expected. PCIe 4.0 and 1.1. Board can give it 2.2 if I'm not mistaken. Let's see. Yeah, it switched to 2.0. Sorry, my bad. All of the shaders in place. No objections temperature-wise. 11 degrees between hotspot and normal core, so that's expected, I would say. Nothing odd. For power perspective, top can be go to 270, normal to 40. Yeah, I mean, there's nothing wrong with that. So I'm gonna go ahead and run the Human. So I want to make it full screen, 1440. I'm just gonna let it run, see if there are any problems, blue screens, crashes, drivers, regular kind of things when GPU has some troubles. And also I'm gonna, check temperature-wise. So Human just finished. I'm gonna run superposition from utilization and temperatures. Looks good. I'm gonna run 1080 extremes. It's 3070. It should be able to handle it. So yeah, superposition test just finished. No crashes, no glitches, no black screens, blue screens, artifacts. Everything looks good. Performance-wise, I also don't have any concerns. From the temperatures perspective, 72C on GPU for 3070 is not a huge heatsink, and 240 watts TDP sounds reasonable for me. I will do more maintenance on this card when the DRMOs and fuse gonna arrive. But yeah, that's it for today's repair. Thank you, everyone. Stay tuned till the next episode.